I did come to the University of Oregon partially because of the green chemistry program. I went back to school as a 35-year-old. I had gotten my first undergraduate degree in psychology, and then I was a middle school science teacher, and then I stayed home with my children. And when I went back to school, we were living in Little Rock, Arkansas, and I went back to take one class in chemistry, and that was 9.5 years ago. My research is in the area of green nanoscience, which we are pioneering, and it is combining green chemistry with nanoscience and developing proactive processes, considering much of the research in nanoscience is focused on the products. Right now you'll hear a lot about nano, and there are products that are being we're taking advantage of the unique properties that we can get from nanoscale. Specifically, we make gold nanoparticles, and most gold nanoparticle syntheses have yields of about 20% of the gold that actually winds up in the product. We were able to increase our yields to 80% of the gold. There are a lot of nanomaterials out there. A lot of quantum dots are made from other metals. There are a lot of silver nanoparticles being used in textiles and things like that now. But we work with gold nanoparticles. Gold nanoparticles have properties that make them look like they're not gold. This vial actually here is, I don't know if you can see, it's gold nanoparticles, and they're kind of reddish purple in color, and that's due to their size. The quantum dots show different colors emitted when they are excited with UV light. And so when they're exposed to UV light, they'll give off a color based on the size of the core of the quantum dot. And so each of those quantum dots is the same material, but a different size. And so it emits a different color. So it's very important that that we can control that size, because otherwise we would not get those clear, distinct colors from the materials. What we've done in the Hutchison lab within the last couple of years is develop a flow synthesis process. And so with that, we use syringe pumps like this with very small tubing, and instead of stirring in a batch in a flask, we flow materials through the tubing, and then collect them. And what that gives us is much broader control of our reaction conditions, and so we're able to make exactly what we want to make.